Imagine your phone charger, except it never stops charging. Now imagine millions of chargers like that, running day and night, hidden inside buildings you never see. That is what is happening right now. Artificial intelligence is spreading across the world, but behind every AI answer, every image, every video, there is something most people never think about. Electricity. Here is the uncomfortable truth. Artificial intelligence is not digital, it is physical. It lives in massive data centers filled with powerful servers, advanced chips, and high-speed networks, all running continuously. And the electricity bill behind this system is growing so fast that it is beginning to reshape power markets, real estate, and national energy policy. This is no longer just a technology story. It is a money story. And it is only getting started. When people hear the word cloud, they imagine something light and invisible. But the cloud is simply a network of physical buildings, huge concrete structures packed with computers that never sleep. Artificial intelligence does not only consume power to think, it consumes power to calculate, to move enormous amounts of data, and to stay cool, because modern AI hardware produces extreme heat. Every second, energy is being converted into computation, and computation is being converted into heat. And that heat must be removed. So the real cost of artificial intelligence is not one answer or one image. The real cost is the always-on infrastructure that supports it. This is why the data center industry is exploding. Around the world, companies are racing to build new facilities, expand existing ones, and secure long-term power supplies. Investment in data centers has surged to record levels, driven largely by artificial intelligence demand. And this demand is very different from traditional internet usage. Traditional internet activity is mostly passive. You watch a video, you read a message, you scroll through photos. Artificial intelligence is active. It performs heavy computation, often repeated many times for millions of users, sometimes for seconds, sometimes for hours, sometimes for days. And the models themselves are becoming larger and more complex. Training advanced AI systems requires massive clusters of computers running continuously, consuming enormous amounts of electricity. At the same time, artificial intelligence is expanding beyond text, images, video, voice, real-time assistance. Each of these requires far more computing power than simple text. The result is a surge in electricity demand that energy systems were not designed to handle. And the question is no longer whether this matters. The question is how big this problem will become. To understand why this matters, we need to talk about electricity grids. Power grids were built for predictable growth. Population increases slowly. Cities expand gradually. Industry develops over decades. Artificial intelligence breaks that model. A single large data center can consume as much electricity as an industrial complex or even a small city. And unlike traditional users, AI systems require constant, reliable power. They cannot simply shut down during peak hours. This creates a serious challenge. Permits for new power plants take years. Transmission lines take years to build. Transformers and grid equipment face long manufacturing delays, and local communities increasingly resist new infrastructure. At first, governments welcomed data centers. They brought jobs, investment, and prestige. But now many regions are discovering the hidden costs: grid stress, rising electricity prices, water consumption for cooling, public opposition. Artificial intelligence is no longer competing only for advanced chips. It is competing for electricity itself. This competition has triggered a new kind of arms race. Technology companies are racing to secure long-term power supplies, not short-term contracts, decade-long commitments, because without electricity, artificial intelligence does not scale. This is why discussions around energy have intensified. Renewables play an important role, but they are not always available when demand peaks, so companies are exploring every option. Wind, solar, battery storage, grid upgrades, and increasingly nuclear energy, not because it is trendy, but because it provides stable, continuous power at scale. Whether nuclear becomes a major solution or not is still uncertain, but the signal is clear. Energy is becoming the limiting factor for artificial intelligence growth. And when a critical resource becomes scarce, its value rises. This is where the financial implications become impossible to ignore. Electricity is no longer just a utility cost. It is a strategic asset. Regions with abundant, reliable power gain an advantage. Regions with constrained grids fall behind. This dynamic is already influencing where data centers are built and where investment flows. And it is quietly reshaping the economic map. When a megatrend demands more electricity, money follows the power. This is the part most people overlook. Artificial intelligence is not only creating winners in software, it is creating winners in the physical world. Data center real estate is becoming one of the most valuable forms of infrastructure. These are not warehouses. They are mission-critical facilities. Power generation is seeing renewed interest as guaranteed demand attracts long-term investment. Grid infrastructure is suddenly valuable again. Transmission lines, substations, transformers. The boring parts of the energy system are becoming strategic assets. Cooling technologies and energy efficiency solutions are gaining importance. Because when power is scarce, efficiency becomes profit. Even geography matters. Regions that can provide stable electricity, supportive regulation, and community acceptance are attracting massive investment. Artificial intelligence is changing how money moves, and it is doing so quietly. So what happens next? There are two possible futures. In one future, artificial intelligence becomes more efficient, better chips, smarter models, improved cooling. Electricity demand still grows, but at a manageable pace. In the other future, artificial intelligence becomes embedded into everything: work, education, entertainment, healthcare. And the electricity demand continues to rise faster than infrastructure can adapt. In that world, energy becomes the bottleneck, and artificial intelligence becomes more expensive to operate. This leads to a surprising conclusion. The next major breakthrough in artificial intelligence may not come from software. It may come from energy, from how we generate it, from how we store it, from how we deliver it. Artificial intelligence is forcing the digital world to collide with the physical one, and the electricity is the bridge between them. So the next time someone says artificial intelligence is just software, remember this: every AI response is powered by real electricity, real infrastructure, and real money. And the companies, regions, and systems that control energy will help shape the future of artificial intelligence itself.